This is question 5 from the SACE Stage 2 Physics Course Companion from Chapter 2.1, Electric Fields. Here we have 3 charges in a row. Q2 and Q1 are separated by x centimeters. Q1 and Q3 are separated by some other distance, and the distance between Q2 and Q3 is 1 meter. We need to find the value of x such that the net force acting on Q1 is 0. So if we have the distance between Q1 and Q2 is x, and the distance between Q3 and Q2 is 1 meter, that means that distance here must be 1 take x. So now we can just use Coulomb's law to work out what the value of x is going to be. So using similar notation to before, we'll write F12 has to be equal to F13, and then substituting in our expression of Coulomb's law, so F Q1 Q2 on x squared, so messy, equals 1 on 4 pi epsilon naught Q1 Q3 on 1 take x all squared, so we can do some cancelling out. So we have Q2 on x squared equals Q3 on 1 take x squared. Now there are 2 ways to proceed from here. If you're using your graphics calculator, that's very straightforward. So graphic display calculator, Q2 is 2 microcoulombs. So we have 2 times 10 to the power of minus 6 on x squared equals, and Q3 is 6 microcoulombs. One take x squared, and you can find out that x using your graphics display calculator is about 0.37 meters, which is 37 centimeters. Since this is more of a learning question rather than an assessment question, some of you might be happy with that, but if you want to go through the algebra, which is a little bit more challenging but still worthwhile, then I'll just do that now anyway. So here, coming down here, I'm going to cross multiply the x squared and the Q3. So we get x squared on 1 take x squared equals Q2 over Q3. And if we square root both sides, we'll get x on 1 take x is the square root of Q2 on Q3. Now I'm going to multiply through by 1 take x. So we have x is root Q2 on Q3 multiplied by 1 take x. And we're just going to expand that out. So Q2 on Q3 times 1 take root Q2 on Q3 times x, and I'm going to plus the root Q2 on Q3 x over to the other side. So we have x plus root Q2 on Q3 x equals root Q2 on Q3, almost there. We can factor out the x on the left hand side, so that becomes 1 plus root Q2 on Q3 equals root Q2 on Q3. So finally, x equals root Q2 on Q3 divided by 1 plus root Q2 on Q3. And we can substitute our values into here now. Since, let's do it. So Q2 is 2 microcoulombs, so 2 times 10 to the minus 6 all over 6 times 10 to the minus 6 divided by 1 plus that same expression. And if we substitute that into our calculator, it's much easier if we just get rid of the scale factors here because they just cancel out with each other. And lo and behold, we get 0.37 meters or 37 centimeters. So this is a lot of algebra. It's more for if algebra is your thing rather than using your graphics display calculator. It's more of a really good learning activity rather than an assessment activity. The algebra is a little bit too heavy, most likely that you'd see in a test, but it's still worthwhile going through it anyway. It's a nice question, and just a little bit unusual and gets you thinking about the algebra and what's going on a little bit more than just straight use of Coulomb's law. Well, I hope you enjoyed that, and yeah, that's it for question 5.